Hey guys, hope you're all doing well. So this is our first lesson of going into some Algebra 2 stuff to get you guys ready for next year. I posted a helpful little link to show you how to change your my.hrw website so that you'll be looking at the Algebra 2 stuff on there. And like I said on that post, instead of like doing a deep dive into just one thing, we're just going to touch on our first one is going to be 1.3, transformations of function graphs. So the graph of any function f of x can be transformed in a variety of ways. So I've got some examples set up. So translating vertically or horizontally, that's just shifting up or down or left or right. So let's look at vertical f's. So we add or subtract to the outside of the function. Here's our original f of x, our parabola right here. So to go up, we add to the outside of our function. So here's our f of x plus c on the outside, and to shift down, as you might guess, it holds the same shape. We just subtract whatever amount of units we're shifting up or down. That's our c. That's our constant that we're going to be adding or subtracting to our. Horizontally, to add or subtract to the inside of the function. So notice here where we've got the inside of the function here, horizontal, left or right shifting, and the outside of the function here for vertical, up or down. That's the difference. That's the clue to let you know. So to go, it's kind of counterintuitive for horizontal. To go left, you add. So to go left, we add c on the inside. Put those parentheses around it to show that it needs to be on the inside of the function. And to go to the right, we subtract on the inside. That's the horizontal, is the inside. Addition moves you left, subtraction moves you right. And once again, that C tells you how many units you're shifting left or right. Okay, so reflecting vertically or horizontally, all we do is put a negative sign in there. So depending on where that negative sign goes, tells you whether you're going to be flipping across the x-axis or across the y-axis. I've got these already set up. Here's our f of x, this is our original equation. When we negate the outside of our function out here, the outside, that means we're reflecting across the x-axis. Here's our x right here. So when we've got a negative on the outside, we flip across that. It's flipped straight down. And then our y-axis flip, our negative is on the inside there. So that means we go across. Now, over here, here's our y-axis, right? So when we've got a negative on the inside of our function, it just flips right across the y-axis like that. Okay, let's talk about stretching or compressing. So we can do a vertical stretch or compression and a horizontal stretch or compression. These are also kind of opposites, what I mean. So horizontally, let's start with vertically. Vertically, we're on the outside. So what we're multiplying our function by is on the outside of our function. Outside, outside. So to stretch it, to make it longer vertically, we multiply by a number greater than 1. So if we're stretching vertically, we kind of make it longer. Here's our vertical stretch. That's multiplying on the outside. And multiplying on the inside, we'll make that one blue. or I'm sorry, not multiplying, still multiplying on the outside. Every time you multiply on the outside, that's a vertical stretch. Depending on the number, if it's greater than 1, it's stretched. If it's less than 1, it's compressed, it's squished. So it's going to be, that's our blue. Press is in blue. And then our stretch. And then the same thing with the horizontal. So to stretch or compress horizontally, we're multiplying the inside of our function. And depending on whether that number is greater than 1 or less than 1, depends on whether we stretch it or compress it horizontally. I'll show you what I mean. So to stretch, to make it longer horizontally, we multiply the inside by a number less than 1 but greater than 0. So it stays basically the same, but it's just stretched. Red, it's stretched. And then let's switch over to blue for compress. So we're still multiplying the inside. That's your clue. Inside always, multiplying the function on the inside of the function always means that the change, our stretch or compression, is happening horizontally. So when that number is greater than 1, when we're multiplying by a number greater than 1 on the inside, that is compressed horizontally, squished on the inside. Now, if you'll look, that's the opposite to vertical. So when we did vertical, it was both on the outside, right? First thing you should check to see if it's on the inside or the outside. If you've got a number that you're multiplying on the outside of your function, you know that the change is happening vertically. Then you check, is my number greater than 1, or is it somewhere in between 0 and 1? If it's greater than 1, that means we're stretching. If it's in between 0 and 1, that means we're compressing. Now, horizontally, if we're multiplying to the inside of the function, like we are here, that means it's going to be a horizontal stretch. So, but it's the opposite. To stretch horizontally, our number needs to be in between 0 and 1. And to compress horizontally, our number needs to be greater than 1. So you can apply all these different rules to figure out what's happening to your function. Take a look. Let's take a look at some examples here. Here's our function here, right? Here's our original f of x is right there. And there's all kinds of different things happening, right? Well, first of all, we've got, we've got a negative on the outside. That means we're reflecting over the x-axis, right? We're also multiplying on the outside, right? And it's by a number in between 0 and 1. Multiply on the outside means it's vertical. We know that it's going to be a vertical compression or stretch. And since the number is 1/2, we know that it's going to be a compression. Compression by 1/2. Let's take a look at the next. Okay. It's also being multiplied on the inside of the function, right? Since it's being multiplied on the inside, we know that the change is happening horizontally. And since it's a number greater than 1, we know that it's being compressed horizontally by 3. And if you, you'll constantly be referring back to these rules here to figure out what's happening. So, just have this up as your reference, and you'll quickly be able to figure out everything that's happening. There's some other things that are going on. Also, we're adding a 1 to the inside of the function, right? So inside means we go left or right. So since we're adding, we know that we're going left 1, left 1. And there's one more thing happening to the graph. subtracting 5 on the outside. So adding or subtracting on the outside means we're moving the graph vertically. Since it's -5, we know we're going down. We're translating down 5. So that's kind of a mishmash of everything all together. And that's kind of how you break it down to figure out everything that's happening. And then here, our next example, this is just all the different things that are happening to our graph. Our parent graph right here, here's what we started with. There's our original f of x. So our example is asking us to write g of x. G of x is going to be all the different translated functions of our original function here, our f of x, in terms of f of x after the corresponding translation. Okay, let's look at the green one. The green one is a horizontal compression by 1/2. Okay. So horizontal compression means we're squishing it. It's going down by 1/2, which means we need to multiply by a number greater than 1. We take that 1/2, we flip it, so our g of x becomes f of 2x. We need to multiply to the inside. We know that our change is happening horizontally, therefore it's by 2 times. Okay, number 2, our red is a vertical compression by 1/2. So that one's easier. We don't have to mess with the fraction. Our vertical compression by 1/2, it's being squished down, which means we multiply the outside by 1/2. And then our translation here. So here's our original equation. We know that it's a vertical shift down 2. So down 2 means we subtract 3 from the outside of the function. And then left 2 means we add 2 to the inside of the function. It just takes a little practice. Since we're covering 2 sections, in this one we're going to do 1.3 and 1.4. You don't have a ton of homework for each section. So take a look at the homeworks. They should correspond pretty directly to the notes. Let me know if you have any questions. All right.